Okay, good morning everyone. So today we will going to show you one demo over how we will going to process the SLC product of the SAR in SNAP and how we will take it in ArcGIS Pro. So last time the video which you seen, that is the GRT product which I actually processed. Okay, so in SLC what you will get advantage, you will get the phase and amplitude both the data together. Okay, so that the advantage we will get. So one side you can calculate the intensity, and even other side you can calculate the coherence also. So and the coherence is actually a very sensitive with urban bodies. So if you are going to see any kind of changes inside the urban, so then obviously SLC product is a very important part for that. Okay, so let's start with the SLC data product, how we are actually going to process it. Okay, so first thing is you have to take your data which you have inside here. So I already have two dates actually. One dates I already exported, so I am going to show you one date only, like this date which I am going to take these data sets. Okay, so this data sets is over the Bangalore city only, and that is over 2020 data sets which I am going to take it here. Okay, so simply drag and drop these data sets inside this. Okay, so that it will come simply like this. Okay, so this is the first thing which you are actually doing, that how we are going to add the SLC data. So if you just expand, you can able to see the bands. Okay, so there is so many bands you can able to see over the intensity bands. Okay, like VV and VH both I will be there. So I hope you have, I already explained in my last video that what is the VV and what is the VH. So it is just a sending signal and receiving the signals. So on the basis of that we are actually going to use the radar images. Okay, so first thing which we're going to do, we're going to do the subset of the image. Okay, so we do not require this whole image, so we'll go to the radar and sentinel one top splits. So this is the very first steps we are going to take it. So in the processing parameters, if you see here, you have different white mode, interferometric white mode. So if you just see this IW2, which is actually covering my location of the Bangalore city. Okay, so now in a burst you can take see, for I just take it for the 2 to 4, sorry, 4 to 8, so that I'm just taking it for that. Okay, so just a minute. So this is a 4 to 8, I'm just taking it. Okay, so if you see the file name which we're going to get is a split. So or whatever the processing we will going to do, so the last name is very important for that. Okay, so I'm just simply running it. So let's see how this results is actually coming. Okay, so we will wait few minutes to see the processing, how it is actually coming. So in general, first it will take few minutes time to process this data. Then once you've done that, then you will get the split image. Okay, so so this is actually the way of you can go for it. Okay, so this is basically we are actually going for the similar way. Okay, okay, so once you have done this, okay, so you just see here, you will get a split product like this. Okay, so you already have the split product. Okay, so now after splitting, this is actually split, you just see the split product, it will going to show you. So what we will have to do, the next part is we have to go for the orbital correction. Okay, so the precise orbit we have to apply for this. So you have to go to the radar, then apply orbit file. Okay, and you just select the C which products you are actually going to apply. Okay, so that is very important, means here whenever you are processing, the processing file you should be selected for that. Okay, otherwise it will not going to run. So this is the proper way. Okay, so for the selection, you just see here, this is a split product, so this is your split product, so you have to select that split product only. So it is by default, it is selecting the top one. Okay, so in the processing parameters, you just see you should use this do not fail to new orbit files. So why we are doing this? So a precise orbit means if it is not getting also, so this your processing will not stop. Okay, so now we will going to run this process and let's see how means the output, how it is coming. So let's wait for the output. Okay, so now this orbital file is generated. So what we will going to do, we will going to we will going to use the next steps. Okay, so if you see here, the complex bands and intensity bands both we will get actually. Okay, so now we will going to do the calibration, okay, over this image. Okay, so to doing the calibrations, you have to go to the radar. Okay, so radiometric calibrations you have to go. So radiometric calibration, you have to go here. So you have to select the last whatever products you are actually processed. Okay, and check the processing parameters. You should see the sigma naught bands is actually selected. So you are going to create the sigma naught from here only. Okay, so let's run it. So now my calibration file is ready. So the next process which we will going to run, that is the debasing. Okay, so this you see here in this particular image which you are actually open now, sigma naught band 1, H and 2. So if you just open this, suppose VV band I am just opening, see here, so you will get some lines in between. Okay, so what we are actually doing, we are actually trying to removing these lines using the debasing. Okay, so that the process only we are going to do in the debasing what we are doing. So let's go to the radar Sentinel 1 tops, it's debasing. Okay, so you have to select the proper file. So you have to select from the 4. Okay, so leave everything as a default. Okay, so let's, so from the last name db or db, you will understand the debasing. So let's run the output and let's wait for it. Okay, so it is going very fast. Okay, so now we have the debased image. So you can open the debased image and you can able to see the lines, the black lines which is coming in between. So those are actually to just see here. Okay, so both it is removed. Now the next process which we will going to do, that is the multi-looking. So multi-looking is doing what? So basically the radar image is not exact the square pixels. Okay, as you know about the azimuth and range resolution is different, the square pixel is not created. So what, due to that, to creating the square pixels, we are actually going to apply this multi-loop process. Okay, so to doing this multi-loop process, what we will going to do is go to radar utility and go to the multi-loop parameters. Okay, so here you have to select this, and here in by default it is coming as a that port, this as 411. I'm going for the default only. Okay, and pixel size is 14 pixels it will going to come. So let's see, after multi-loop you will get as a multi-loop output. Okay, so let's run the multi-loop process. So we will wait few minutes for the multi-loop outputs, and once it generate, we can check the multi-loop output how it is coming. Okay, so here just you will see the multi-look image. After multi-look image means we will going to see how it is coming, so that you will get an idea about the multi-look products. Okay, so simply go here, and if you see here, this is VH image, and if you open this VV, so you just see VV will get a better information over the urban, okay, than the VH. Okay, so this is the way actually you have to understand which process is useful for what particular object you are actually targeting. So if you go for the suppose in case of flood area analysis, then maybe VH will give you the better results on that. Or so in that scenario, so VV is giving better results over the urban because of the double bouncing, okay, effect over the urban areas. Okay, so that the concept which you have to understand whenever you're using the radar images. This is not like simple multispectrals which we are actually usually processed over many softwares. Okay, so the concept is very important here, how what kind of data sets you are actually using it here. Okay, so now the same thing. So if you want to create a histogram of this, see here its histogram is actually concentrated. So you want to do the histogram stretching as you usually do over the multispectral. So for that you have to convert it at a linear. Okay, so linear to dB you have to create. So then only you can control the histogram is very easier mode. So if I click or simply on this, okay, and you just see here now. So this is your how it is, this histogram you can control now. So if I want, I can control the histogram now. Yes, okay, so this is the easier way to control your histogram. Okay, so you can make a better uh, visualizations over your image using this kind of stretching techniques. Okay, so now the final steps which you have to do, that is the geometric correction which you have to do. Okay, so let's start to do that. Okay, so we will go to the radar, then geometric terrain corrections. So you have to do geometric terrain corrections and range of the terrain corrections. Okay, so this is the process which you have to apply. So now you have to give the last input. Okay, and then processing parameters, you have to go here and leave everything is here. So what it is actually doing in background, it is downloading the SRTM dataset. So you have various products will be there. So usually I use these products only, SRTM TS auto download. Okay, so using this it is actually doing your geometry corrections. Okay, so you will get this output which will be the geometry corrected over this. So after this you can take this data in any software, you can do process as we will going to do it for the ArcGIS Pro. Okay, so let's run it and just see the output. Okay, so what it is actually doing, it is taking a few minutes time. It is downloading the DEM in the background, and using this it is going to geometry corrected your this radar images. Okay, so so once it is done, you can directly open this image and you can start working whatever the analysis you want for the classifications, feature extractions, whatever you want, you can able to do it over this particular image. Okay, so just let's see the output and then you will get an idea. Okay, so I will go there, and the final output is this one. Okay, so you can expand the band and you can see this is the H and this is your VV, and see how nicely VV is showing your urban area. Okay, so that's the process which we are actually going to apply over it. So similarly, if you want to create a better histogram to control it, see, because here you can't able to see this a 3 triangle will see now, so to doing the stretching, so you will not able to see because it's a concentrate value will come. So once you do the the see linear to dB, if you convert, okay, so automatically you have option for the stretching of your this particular image. You can expand it. Okay, the rest process will be the same, like you just take your image, just save it in a TIFF format from this. Okay, you have to save this product. Okay, so this is the save product as, so you have options. Okay, so you can save it. Okay, so or here also see here so import also you can do. Okay, so generic formats. Okay, so many formats will be there. GeoTIFF formats is there, so you just import your this particular image in a GeoTIFF, and then you can simply take it in ArcGIS Pro. And better is you always just see here there is import options will be there now. So whenever you are going for the generic formats, so there is various formats you will get actually. Okay, so so any of the formats you can convert it. Okay, so NV format is there, GeoTIFF format is there, so you can convert it and you can take your image and you can process it. Okay, so that's the advantage of this tutorial, like means many people is asking this processor how you actually going to calculate this two thing. Means one is in GRD data. I already showed you how to process it and how we'll take it in ArcGIS Pro. Similarly, you have to do the same process over this image, and you want to take it in ArcGIS Pro also. Okay, so how we'll going to take it in ArcGIS Pro? It is very easy process. Okay, I'm just telling you the process, so you can just get an idea if you want to do any analysis over that. So usually you can go to this file, okay, and then you have options for the export, okay, and then simply click on this geotiff to export. So wherever is your locations, you can just simply save it and go to export. So I already did it, so it is taking a few minutes of time, so that's why I'm just showing you like this. Okay, so if you see here, that is in general, just you just simply take this, okay, file, okay, to ArcGIS Pro, and as I just already transfer it, so how it is looking in ArcGIS Pro, it is something like this. But here, you at a time whenever you are opening a band, it is actually coming with stack bands, so that's why it is coming like this. So what you have to do, if you want to do the single bands, then see, you have, if you scroll down, you will get a two bands, 1 and 2. So one bands, if you want to display, just simply you can display, select the 111 bands, and you can separate. So you just need to do the add data, and wherever your data sets will be there. So this is your file out TC. Okay, so the TC will be file and output. If you just see here, this is TC. Okay, so that only I just open, and once pyramid layer will create, so you can see. So you just see here, if you want to see the band 2, so that simply change it the band 2, so you can see the band. And if you want to create the composites, and then you required one more bands, you can create, like usually we use this for the kind of flood based analysis we are going to do. So in that case, VV, VH, and the ratio of VV and VH also you can create. Okay, and using that you can create the composite band, so that is also possible. Okay, so if you want to create this is to the linear, okay, so that also you can do. I already tell you about that. Okay, so this is the linear to dB, you can create it. Okay, and this also you can create a linear to dB. Okay, so this is you can do, and you can add it with this particular band if you want. Okay, so that is the process how we are converting in dB. And if you want few more extra band, if you are want to create, okay, so that is also possible to create using the band mat. Okay, so what the band mat is doing means, if I want to create a the ratio of the two bands, okay, so that I can create using this band mat tool. So here you have this raster, and this band mat options also there. Okay, so new name you can give some name like ratio bands, you can give some name like this. Okay, and here you can mix expression like whatever the process you want to do now. So ratio, I want to create a ratio of VV and VH, so you can give a name like that, ratio of VV underscore VH. Okay, so you can give some name like this, so that you can identify in proper way. And you just see, it will be the newly created band will be this. So whatever it will be there, you can make, remove, and here what we are actually doing, a single click you have to do. And first you can click this one, and then second you can click this one. Okay, so that also you can able to add with this particular informations, and then click on OK. So this is the another band you will get. Okay, like this is, if you just see here, this is the ratio on VV and VH. Okay, so this also you can create linear to dB if you want. Okay, So you just, it is already in DB actually, you need not to create on it. Yes, it is that only. So you need not to create that because it's a product. Okay, so that is not required, so you can simply delete it. So this is your main file. Okay, so that is the process. Now you will get a 3 bands, VVVH and ratio and VVVH. Okay, so you can use it for any kind of composite if you want to create. Okay, okay, so you just see here using this particular theme, so you can go to the windows and open window RGB. So I am RGB only, I just created this composite image. So radar composite image is not like a multispectral composite image, it is something looking different which you have to interpret accordingly. Okay, so that's all. So similarly you can take it in ArcGIS Pro also, the same thing, and you can open this 3 bands in a composite and you can create a color band, color composite like this also. Okay, so that's all from my side. Okay, so you can do the analysis like this way. I hope this video will be very helpful to giving you an idea about if you want to do any kind of processing in Sentinel 1 SLC product, and how we're going to do the analysis in SNAP and how we'll take it in ArcGIS Pro and you do your own analysis. So that's all from my side. So I hope you like my video. Please subscribe my channels. I will come with a new video, a new knowledge, and I will always happy to share it with you. Thank you very much.